Okay, morning everybody. We're going to do a lesson today on volumes of cones and spheres and cylinders, and we'll even talk about pyramids. This is on the higher tier papers of maths and numeracy, especially on the numeracy. It can be up to like a 10-mark question, so it's really important that we can deal with it and handle them, right? So at the top of the sheet here, I've managed to put in what they give you on the front of the exam paper, right? They tell you that the volume of a sphere is 4/3 times pi r cubed, where r is the radius. They tell you that the surface area of a sphere is 4 pi r squared. You don't need to learn them, it's given to you. They also give you the formulas for a cone. The volume of a cone is 1/3 pi r squared h, where h is the perpendicular height. And they give you the formula for the curved surface area of a cone, which is just pi times r times L, where L is what we call the slant height, right? So you won't need to memorize them, but you will need to remember that the area of a circle is pi r squared. You will need to remember that the circumference of a circle is pi times diameter. And you will also need to know, especially for your My Maths homework, that the volume of a pyramid is 1/3 times the length times the base times the perpendicular height. Okay, so maybe a bit boring here. Boring fact, you might have noticed that the volume of a cone is 1/3 pi r squared h, and pi r squared h is the volume of the whole cylinder. So a cone in this cylinder is 1/3 of the cylinder. And you might have noticed the same for the pyramid. A pyramid is 1/3 of the volume of the box, which is weird, right? But a little fact for you there. So we're going to do 4 questions. 4 questions, and then you'll have your Google quiz. And then tomorrow, as normal, you'll have your My Maths walkthrough and the My Maths task, right? So let's have a look at this first question here. It's worth 4 marks. It's not overly difficult. It just takes you, you have to take your time, really, and press your bits of plastic carefully. It says, a cone is joined to a cylinder as shown below. The cone has a base radius of 11 and a slant height of 13. So we know that this distance here is 11 and this distance here is 13. The cylinder has the same radius. So the radius of the cylinder is 11 and the height of the cylinder is 17. So that's the information they've given us. And the question is, calculate the total surface area of the composite solid. Don't forget the word composite just means there's more than one shape going on there, right? And total is in bold. And there's a reason for that, is because this is what most kids do and make a mistake. They'll work out the surface area of the cone, no problem, pi r/l, we can do that. They'll work out the curved surface area of that cylinder there, but then they'll forget to work out the area of the circle on the bottom. Right, so there's 3 things we've got to work out. We've got to work out the surface area of the cone, the surface area of the cylinder, and then the circle at the bottom. And once we've worked those 3 things out, obviously we just add them all up. Okay. Now don't forget, for the cone, it's pi times radius times length, and they've given us the numbers, so I'm going to let you have a go at this on your own. The circle at the bottom is pi times radius squared, and again, we know the radius is 11. So it's this bit here that takes a bit of thinking. The surface area of this curved part of the cylinder. So what I wanted to think of is, if you had an old inside of a toilet roll, the cardboard roll, that's a cylinder, and if you cut it and open it out, it would actually be a rectangle, wouldn't it? So what you're doing here when you find the curved surface area of the cylinder is you're finding the area of a rectangle. And we know in this case that the height of it is 17, but obviously what we don't know is the length of it. I would hope you agree that the length of this rectangle is actually the circumference of the circle. Right? If I could cut it here and open it out, the length of that rectangle would be the circumference of that circle, which is pi times diameter. Now, of course, they haven't given us the diameter, they've given us the radius, but we know we can just double that then to get the diameter. All right, so I'm going to give you 2 minutes. I'll try and look up another amazing joke. I'll give you 2 minutes to see how far you can get, and then I'll model the answers. Right? If you have any questions, by all means, feel free to speak, but that's never going to happen. So put it in the chat if you want to ask me a question. Right? I'm staying right here, but by now you should have done the surface area of the cone. Done. There's my phone. You should have done the area of the circle at the bottom, and you should be plowing through the rectangle bit in the middle. Okay. Right, I'm just going to take this call. Hello. Hi, Anne, right? Same timetable for every week. I'm in the lesson now, so there's 47 kids in the lesson, so it's definitely going on. Ah, right. It's best you ring Bouncy's room for year 7. I'm doing year 10 and 11. But yeah, it's the same one every week. Yeah. Yeah. Thank you. Bye-bye. Right. Apologies about that. Someone else's live lesson. I can't log on. So, right, I'm going to go through it. Right, pi times radius times length. Now I'm going to give you a tip here, and I'm going to keep everything in terms of pi until the very end, because it just makes it a bit easier. So if the radius is 11 and the slant height of the cone is 13, 13 11s are 143, so that's 143 pi. The circle bit at the bottom, pi times radius squared, 11 squared is 121, so that's 121 pi. So it's this rectangular bit in the middle. The diameter is 22, double 11. 22 times 17 is 374 pi. And if I add all three of those up, that'll give me the total surface area in terms of pi. I think I've got 608. That'll give me the total surface area in terms of pi. I think I've got 638 pi centimeters squared. And do you know what? If you left it like that, you'd get full marks. It's absolutely brilliant. It doesn't tell you to do it to 1 decimal place or 2 decimal places. But I imagine most of you did multiply by pi and have a decimal in front of you. And if you've done it correctly, you should get 2004.3 centimeters squared. Note this is squared because we found out an area and not a volume. Right? Anyone brave enough to say, yay, I had that, sir, or boo, I completely messed that up? Anybody get something similar to that? Well done, well done, well done. Hey, but what a fab start. Awesome. Any ideas where you made your mistake, Alicia? Bill, any ideas where you made your mistake? On, Karis. Okay, well, I'll leave the solution there for a second, have a little look, and then we will look at question number 2. Don't forget the formula for the cone was given to you at the start of the exam paper, right? But you will have to memorize the area of the circle, the circumference of the circle. Right, let's have a look at the next one then. So now straight away you can tell this is off a numeracy paper. Quite a lot of words. It's worth 7 marks. And that's a lot of marks, right? You don't generally get 7-mark questions on the maths paper. So let's have a look at this one. Similar looking shape, isn't it? It's a cone on top of a cylinder, but it's upside down. Right? It says gardeners can apply weed killer to large areas of land by using a spray gun. That's irrelevant. Who cares? Weed killer is stored in a large bottle that gardeners carry on their backs, and this feeds the spray gun. What's the point of that? They're just trying to put you off already. Let's get to the chase. The gardening company has designed the bottle shown below. It consists of a hollow cylinder and cone that are joined, right? So all of that is just to throw you off. We have eyes, we can see it's a cylinder and a cone. So where's the maths? Where's the question? It says the base radius of the cone and the radius of the cylinder are both 9, right? Well, I like to label it in. It instills me with confidence. There we go. It says the height of the cylinder is 4 times the vertical height of the cone. Oh dear. So it's not giving us the height. That's a shame. But it is telling us that this one here is 4 times bigger than this one here. Okay. The bottle has been designed so that it has a capacity of 10 litres. Right, straight away you can see why this is worth 7 marks. Capacity, don't forget, is just another word for volume of a liquid. Right, so you need to know that. And 10 litres is the same as 10,000 centimetres cubed. Right, there are 1,000 centimetres cubed in a litre. So you needed to know those two things. You needed to know the word capacity meant volume, and 10 litres was 10,000 centimetres cubed. The actual question is, what's the total height of the bottle? Now, this is much more tricky than the first one, isn't it? Now, let's go back to this height. It says the height of the cylinder is 4 times the vertical height of the cone, and obviously we know neither. So I'm going to call the vertical height of the cone X. Usually pick the letter X, don't we? And the height of the cylinder is 4 times bigger than it, so I'm going to call it 4x. Now, let's have a look. They've given us the total volume. We know the formulas for volume of a cylinder. They give us the formula for volume of a cone. So if I add up both of those, and I know the volume, I can do some playing around and division at the end and get that total height. All right, so let's have a crack. I think I'll model this one with you as we go along. All right, so we know that the total volume is 10,000 centimeters cubed. I'm not going to write the units every time. You need to know that the volume of the cylinder is pi times r squared times h. It's basically the area of the circle times by the height, okay? And I know the radius is 9. 9 squared is 81. So the volume of the cylinder is 81 pi times by this height that we don't know, but we do know for the cylinder it's 4x. So I should have wrote 4x there. All right, let me go through that again, because that's quite tricky. The volume of the cylinder is pi times radius squared times height. The radius is 9, 9 squared is 81, so that's 81 pi. The height of this cylinder, we've called it 4x, because it's 4 times bigger than the cone. I can simplify this again now. I can do that 81 times 4. 8 4s is 32, so that's 324. So have a look at that. So the volume of that cylinder is 324 pi times x. And if you wanted to get an actual decimal number for that, you could, right? I just find it easier to leave it in terms of pi. Right, well done for staying with me. Now let's have a look at the cone. The volume of the cone, and don't forget, they give you this formula. It's 1/3 pi r squared h. Now, let's chuck in our numbers then. So that's 1/3 times pi. R squared, 9 squared is 81, times by this height, which we've called x. And if we tidy all of that up, 1/3 of 81 is 27. So the volume of that cone is 27 pi times this height we're trying to find, x. Any questions so far? I imagine you've all left right now and I've gone to make a cup of tea. So the total volume is this plus this. So I got 324 pi x plus 27 pi x. So I can just add them up, which gives me 351 pi x. And they've told us in the question that that equals 10 litres. That equals 10,000 centimetres cubed. So if I want to work out this value of x now, I'm just going to take this 351 pi, take it over, and it'll become a divide. Obviously, it's times in by x over here. So when I take it over, it will become a divide, right? So the value of x is 10,000 divided by 351 pi. Now, before you type it in, before you get the actual answer, let's have a little look at the original diagram and make sure we get some idea of what the answer should be. If this distance from here to here is 9, and I know it's not drawn to scale, right? But if your answer is something like 2,500, you've messed it up, right? Or if it's minus the square root of 7, you've messed it up. If you look at it, it's not too dissimilar to this 9 here. So it's going to be in the ballpark of around that number 9. So if you check 10,000 divided by 351 pi in your calculator, you get 9.07 centimeters. And if you were doing this in an exam, you'd think, oh, awesome, that sounds and looks about right. And then I know in a lot of you that I do, you'd be flustered and you'd move on to the next question, feeling really chuffed, and you haven't actually answered this question. The question asks for, calculate the total height of the whole bottle. Okay, so the total height is actually 4x plus 1x, which is 5 lots of x. So the total height is 5 times that. And we can do it on our head. That's 45.35 centimeters. Now that is a juicy question. And another reason I saw kids lose marks on this, they put centimeters cubed at the end, and of course we're finding a height. So it's just a length, which is centimeters. Now let's break that down now, right? That was a tough question, it's with 7 marks. And if you answer 3 7-mark questions correctly on your exam, that's a B grade straight away. So if you think about it, the volume of a cylinder, it's not difficult. The volume of a cone, they give us the formula. It's not difficult. You just have to have the mathematical nous, really, to label the unknown height x and then the other unknown height 4x and have the confidence to see it through. And it is a confidence thing, right? Because, you know, that's not an easy question. That is an A grade numeracy question. Right, so I'll just leave that up there for 30 seconds if any of you want to jot that down. Don't freak out if you were a little bit lost on that one. I am only doing the A and A star questions with you lot in our live lesson, so you know they are going to be difficult, and especially with you not being here to ask for help and support. But don't lose heart, right? Stick at it. Okay, let's go to number 3. Anybody want to say anything? Okie dokie. Should we have a joke break? I got a good one. Anybody want to hear another classic dad joke? Okay. This was just me checking you were still there. Hello, Samson, mate. I didn't know you was on. Here we go. So I went to the zoo on the weekend and I found a baguette in a cage. I'm pretty sure it was bred in captivity. Yeah? Anything? Oh, come on. Tough crowd. All right, not as good as the first one. Thank you, Mia. I do as well. Bred in captivity, Elisa. It was a baguette in a zoo. Oh, never mind. Right, okay. Question 3. Again, straight away you can tell this is off a numeracy paper. It just looks numeracy-ish. It says a company makes plastic shelf supports for use in kitchen cupboards. Shelf support is made by attaching a cylinder to a right-angled triangular prism. Okay, so before we even look at any of the questions, we're obviously going to have to find the volume of it, aren't we? Right, so we have to find the volume of a cylinder, which is pi r squared h, and we're going to have to find the volume of the triangular prism, which is the area of the triangle multiplied by the length of how far back it goes. Okay, so the cylinder has a diameter of 6 and a length of 9. So we know that the radius, if the diameter is 6, the radius is 3, and the length is 9, that's the height. Right, so we have those, so we can easily find out the volume of the cylinder. The prism has dimensions. C to D is 8, so this side is 8. D to E is 8, so this side is 8. C to E is 11.3, this side is 11.3. And B to C is 10. So this bit is 10. Now, one of those figures there is a dummy number that we do not need. We'll talk about it now. Well, I'll talk about it because you lot don't say anything. Right. The company sells the shelf supports in packs of 500. It needs to know the volume of plastic in 500 shelf supports. Calculate the volume of 500 shelf supports. Right. So I'm going to calculate the volume of one of them and then times it by 500. So I have to calculate the volume of the cylinder, the volume of the triangular prism, add those together, and then multiply it by 500. But come on, you can do this. So the volume of the cylinder is pi r squared h. And the volume of the triangular prism, right, so area of the triangle is half the base times the perpendicular height. So the dummy number here that you don't need is this one. You don't need that. To get the area of this triangle, I'm going to call this the base and that the height, right? Half of that times that gives me this cross-sectional area. And once I've got that, I then times it by the length it goes back, which is this number here. So chuck those numbers in a calculator, get me an answer. Chuck those numbers in a calculator, get me an answer. Add up those two answers to get the total volume of one of these supports, and then multiply it by 500 to get the final answer. All right, I'll give you 60 seconds. You're just pressing bits of plastic. All right, off you go. So for the cylinder, I've got 81 pi millimeters cubed. I'm too lazy to times it by pi yet. Do it at the end. For the triangular prism, I've got a half times 8 times 8 times 10. That's 4, 4 to 32, that's 320 millimeters cubed. Now I'll have to actually times that 81 by the pi, add them together, and that'll give you the volume of 1. And then times it by 500 to get the full marks. And if anybody's really brave, type your final answer into the chat. No. Oh, I'm gutted, mate. I hope you all had fun in the snow yesterday. Whoops. Right, let's stay on task. Okay, so if you add those up, I got 574.5 millimeters cubed, and then I need to times that by 500, and I got 287,250 millimeters cubed. Anybody want to fib and say they had that right? It's not that hard, that one, is it? So come on, somebody had it right. Well done, Maul. That's brilliant. Well done, well done, well done. You forgot to times it by 500. There's always one, always one. Well done, awesome. I must say only girls there have responded positively. Come on, chaps. Right, now we're going to look at the last question, and it's quite nasty. And this came up a couple of years ago and wasn't done very well, which is why I want to go through it. So let's have a look. Again, straight away, you could tell this is a numeracy style question, right? So without reading anything, it looks like it's a drawing pin. We don't seem to know. They've got this 9R, 15R, 12R. That looks confusing. We're obviously going to have to find something to do with the volume. And the first thing I hope you spot is effectively it's a cone on the top, cylinder in the middle, and then what we call a hemisphere at the bottom, right, which is half a sphere. They've given us the formula for the spheres on the front. They've given us the formula for cones on the front. So again, it's that cylinder that's come up on every question that we need to know, right? Volume of cylinder, pi r squared times its height. So let's read it then. A metal round-headed nail can be thought of as a cone sitting on top of a cylinder which sits on top of a hemisphere. The company produces these in different sizes but it's made of the same metal. Each nail has the following dimensions. Right. The height of the cone is 9r. The height of the cylinder is 15r. And the radius of the hemisphere is 12r, where r is the radius of the cylinder and the base radius of the cone. That's this bit here. That's what little r is, okay, on the diagram. It's the radius of the circle at the bottom of the cone and on either end of the cylinder. A metal cuboid with a volume of 18,000 millimeters cubed is melted down and recast to form these nails. And the size of these nails has little r being 0.4. Right, well that's quite handy because now I know what this little r is. Calculate the greatest number of round-headed nails that can be produced. Right, let's take this one step at a time. First of all, they tell us that little r is 0.4. So we now know that the height of the cone is 3.6 because 9 fours are 36. We now know that the height of the cylinder is 6 because 15 times 0.4 is 6. And we now know that the radius of this sphere is 4.8. Right. So can we calculate the volume of one of those pins? Yes, because the volume of the cone is 1/3 pi r squared h. We know that r is 0.4 and we know the height of the cone is 3.6. So you can press some bits of plastic there and get that answer. The volume of the cylinder is just pi r squared h. We know that r is 0.4 and we know the height of the cylinder is now 6. So you can press some bits of plastic and get an answer for that. The volume of the whole sphere at the bottom, I know there isn't a whole sphere, right? There's only half one, but the volume of the whole sphere is 4/3 pi r cubed. We know that r is 4.8, so we can work out the volume of the whole sphere, but then of course we only want half of it because it's a hemisphere, so the volume of the hemisphere is that, and then divide it by 2. So you can press some bits of plastic and get the volume of the hemisphere. Then you're going to add up all of those to get the total volume of 1 pin. And I expect us all to be able to do that now within the next 60 to 90 seconds. Of course, we haven't answered the question. The question is, how many of these pins can I make if I have 18,000 cubic millimeters of the metal needed? So the last thing you will have to do then is divide 18,000 by what you think is the volume of 1 pin, and that'll tell you how many pins you can make, right? I'm gonna leave an awkward silence of about 2 minutes here because I really want to have a crack at it. This is your last one for today, so I want to have a crack at this on your own. I will give you a clue. The answer is less than 100, right? So if your answer is 6 million pins, you've got it wrong. The answer is less than 100. Battle through on your own and have a go, please. Write out every step of working as you go. I'll give you 2 minutes and then we'll finish with another awesome dad joke. Off we go. Right, for my cone, I have 0.6 cubic millimeters. And for my cylinder, I have 3 cubic millimeters. Anybody agreeing so far? Anybody actually doing the question? Yay, yay, yay. Thank you, girls. Don't forget for the sphere, it's pi r cubed, not squared. Okay. Yeah. Right, so my final answer for the total volume of the pin is 235.2 cubic millimeters. I have no idea if that's right or not. It's not like the other one where you can sort of picture, does that sound right? No idea at all, right? But I'm going to go with it. I don't think I've made a mistake. I've checked all my buttons, blah, 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 blah. I always recommend doing these questions twice because it's easy to press a wrong button. So the number of pins I can get would be the volume of material I have, which, what did they say it was? 18,000, divided by the volume of one of these pins. So let's type that in the calculator. And that's what it says, okay? Now the answer is 76 pins. That's the answer. Anybody brave enough or just would like to fib and say they had that? And the common mistake done on this question was kids put 77 pins. They see that 76.5 and they go, oh, right, well, 0.5, I'm going to round it up to 77. And of course, we can't do that in this type of question, okay? I have enough metal to make 76.5 pins. And the question says, calculate the greatest number of whole pins it can make. So that final answer is 76. Right, well done for sticking with that, right? They were all tough questions, which is why they're worth a lot of marks. But they are doable. And I'll repeat again, sorry to harp on, the cone and sphere stuff is on the front of the exam paper. But the cylinder, the circle, and the pyramid, I know we didn't do a pyramid question, but you will in a minute. And the pyramid stuff is not on the front. You have to know that, okay? You have to know it. Your Google quiz now, your quiz has just been uploaded. I just had a ping saying it's gone live. There's 5 questions, as always. You get 1 attempt at it, so take your time pressing those buttons. It's not as hard as any of these, right? It's just find the surface area of this cone, find the volume of this sphere, right? They're not as hard as this, so I expect you to get them all right. And the My Maths, I've got the My Maths here because I did a walkthrough video. The My Maths, right, is just basic stuff like that. No big numeracy questions, just work out the surface area or volumes of these shapes here. And of course, you can see the pyramid comes up on there twice, right? Which is why you need to know that the volume of a pyramid is 1/3 times length times base times height. But how many phone calls can you have in one live lesson? I'll cancel that one. Right, so any questions for me, or are we all cool? And we are now going to do the quiz straight away. Make sure you do it straight away while this is all fresh in your head. If you don't have any questions, I will leave you with another cracking dad joke. So a weasel walks into a bar and the bartender says, wow, I've never served a weasel before. What can I get you? Pop, goes the weasel. Oh. Yeah, well, none of you are coming up with any better, so I'll work on that for next week, right? Thank you, Samson. It is. Do the quiz straight away. Thanks for logging on. Oh, you like that? Oh, well done. I'm pretty sure. Good luck with My Maths. There is a video walkthrough of it. Please watch it. And then manga, as always, on Thursday. Thank you, Taji. I don't know when I'm going to see you back in school, but I hope it's sooner rather than later because it's very quiet and boring here without you lot. See you all soon, right? Bye-bye. Do the quiz. Ta-da. Thank you, Paul. You're welcome. Ta-da. Be safe. Bye, Ella. Later, Dill. Have a good day. You're welcome, Tubbs. Later, Tudgy.